guys. We're going to talk about equivalent fractions today. Now I know we've talked about it a little bit before, earlier in the year when we had our calendar pieces. Remember, equivalent means equal or the same, just like in geometry. The word for equal or the same is congruent. In fractions, when we say two fractions are equal or the same, that word is equivalent, okay? So we're gonna look at some different ways to find equivalent fractions and to make equivalent fractions and to prove that fractions either are or aren't equivalent today. I know you've already been practicing fractions on number lines and strip diagrams of fractions, so we're gonna see it both ways today too. All right, so if I start with this number line, remember, it starts at 0 and ends at 1, right? And we need to have equal sized pieces, so I'm going to do my best to break this number line up into thirds. So sorry if my head gets in the way while I look at this. Right about there is about thirds, and actually I don't like that, and I'm using markers so I can't erase, so I'm going to move this over just a little bit. That looks better to me. So I've got 1, 2, 3 equal jumps, equal-ish, right? So this would be 1 out of the 3, and this is 2 out of the 3. And then if I wanted to show 2 thirds, I would color in 2 of my 3 jumps, right? So that's how you show 2 thirds. Now, an easy way to make equivalent fractions on a model that you've already made is by cutting each section into smaller pieces, but you have to make sure those pieces are equal too. So if I come in and I split each of these sections in half, then what I've got is 2 jumps inside every large jump, right? So then what I've made is I have 1, 2, 3, 4, 5, 6 jumps. So then this is 1 6, this is 2 6, but look, it's in the same spot as 1/3. So we would say that these two fractions are equivalent. And then this is 3 6, this is 4 6. And what do you see there? They're in the same spot, so they must be equivalent. Then we have 5 6. So what we started with was a number line that showed 2 thirds, but by cutting each of those thirds into 2 smaller equal pieces, we ended up with 4 6. 2 thirds and 4 6 are equivalent because they are in the same place on the number line. Okay, so now we're going to try it with a strip diagram. So here I've got a strip diagram that I'm starting, and I'm going to make fourths. Okay, that's really easy because the denominator is an even number, so I can just start cutting things in half. Okay, so I cut this whole rectangle in half, and then I cut each of these pieces in half, and there I have fourths. Okay, so if I wanted to show 3/4, I would color in 3 out of the 4 pieces, right? 1, 2, 3 out of the 4, so that is 3/4. Okay, and then just like I did with the number line, if I wanted to make equivalent fractions, I can just take each of these pieces and cut them into smaller equal pieces. So instead of just cutting each piece in half like I did on the number line, I'm going to cut each piece into 3 smaller pieces, but I need to try to make sure they're equal. So remember, 2 lines will make 3 pieces. So like that, I make 3 pieces, 3 pieces in that section, 3 pieces in that section, and 3 pieces in that last section. Okay, so now where I had 3/4 to begin with, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 out of 10, 11, 12 total pieces. So we could also say that 3/4 is equivalent to 9/12. Okay, does that make sense? All right, so now I'm going to show you how to take two fractions, and you have to decide or prove that they are or aren't equivalent, okay? So if I've got 2/8 and 1/4, and I want to see if they're equivalent or not. 2/8 and 1/4. You can pick the model that's easiest for you to make sure you have equal sized pieces. So you can do number line or you can do strip diagram. I always think that strip diagram's the easiest, and I'm going to show you a real easy way to make sure that both of the holes are the same size, because remember, the size of the hole has to be the same or you can't accurately compare the fractions. So I'm going to start by making just one big rectangle, and then if I just cut it in half like this, then I've got two strip diagrams ready to go, and I know that the holes are the same size because they started with the same size rectangle, right? Okay, so now if I'm going to show 2/8, I look at the denominator to tell me how many total pieces I need to cut that strip diagram into, and so I need 8 pieces. And if 8 is an even number, I can start by finding half. So that's right about there. So then I need 4 pieces on each side, and what do you know? 4 is also an even number, so I can cut each of those pieces in half and go from there. So now I need each of these to have 2 pieces, because that would be 2, 4, 6, 8. So I can just cut each piece in half again. 2, 4, 6, 8. And then to show 2/8, I would color in 2 of the 8 pieces. So now in this bottom strip diagram, I'm going to show 1/4. Okay, so again, I look to the denominator to figure out how many total pieces I need. I need 4 total pieces. And again, 4 is an even number, so I can start by finding half. And half on the bottom should be in the same spot as half on the top was. So I can just continue that line straight down. And if I need 4 equal pieces, I need 2 on each side. So cut it in half, that makes 2. Cut it in half, that makes 2. And then if I wanted to show 1/4, I would color in 1 out of those 4 equal pieces. So 1 out of those 4 equal pieces. And what we can see is that these 2/8 have the same area as this 1/4. So because they have the same amount of space colored in,